Hello, all. Welcome to the day 2 of the daily case study series for grade 12. So, today's question goes like this: from a rectangular cardboard, congruent squares are cut from each corner and folded up to make an open box. The diagram illustrates the dimension of the cardboard. Based on the above information, answer the following questions. First subdivision. If x is the side of the square cut off from each corner of the sheet, then what is the length of the open box? X is the side of the square cut off. So the total length is 45. Left and right, we have to remove x, which gives us 45 minus 2x. So the option is B. Second subdivision. What is the width of the open box? 24 minus x plus x, that is 24 minus 2x. The option is C. Subdivision 3. Volume V of open box is given by. So we know volume is equal to length into breadth into height. We know the length, which is 45 minus 2x, and breadth is 24 minus 2x. Of course, the height of the box will be x. So the option is D. Then subdivision 4. What should be the side of the square to be cut off so that the volume of the box is maximum? So for that, let us utilize this volume that we have figured out. Let's call it as V of x. V of x is equal to 45 minus 2x, 24 minus 2x into x. So on applying the distributive property, we get this for V of x. That is V of x is equal to 1080x minus 138x square plus 4x cube. Differentiating this V of x with respect to x, we get V dash of x is equal to 1080 minus 138 times 2x plus 4 times 3x square, which is equal to 1080 minus 276x plus 12x square. Now let's make this V dash of x is equal to 0. That is 12x square minus 276x plus 1080 is equal to 0. Now dividing this entire expression by 12, we get x square minus 23x plus 90. On factorizing this, we get x minus 18 and x minus 5 is equal to 0. That is, x is equal to 5 and x is equal to 18. Now we just have to check whether both are um, acceptable. If I take 18 for x, if we consider 18, then what happens is, for x is equal to 18, breadth will be 24 minus 2 times 18. This becomes a negative value. Therefore, breadth cannot be negative. Therefore, x is equal to 18 becomes invalid. Hence, we take x is equal to 5. Okay, so this is the critical point. So let us confirm whether we will get a maximum value for volume when the side of the square is taken as 5 centimeter. So for that purpose we have to differentiate this v dash of x. Again, v double dash of x is equal to minus 276 plus 24x. So let's figure out what happens to this v double dash of x when x is equal to 5. Minus 276 plus 24 times 5, which is minus 276 plus 120. This is also a negative value. That means since v double dash of x is negative, then x is equal to 5 is the local maxima. That is, we will achieve maximum volume when x is equal to 5. So the option is 5 centimeter. Subdivision 5. The maximum value of V. The maximum value of V is, we have to utilize that expression that we figured out first. V of x is equal to 45 minus 2x. 45 minus 2x into 24 minus 2x times x. That is 45 minus, we have to put 5 here in the place of x, which is 10, and 24 minus 10 times 5, which is nothing but 2450 centimeter cube. So the option is D. Let's meet tomorrow with one more case study question. Thank you all.